Now that we've decided on the kinds of checks that we want to include in our type checker, let's consider some of the main parts of the implementation. So we now need class T's to represent typed class declarations instead of the class I that we had before. In a class T, we still have a supername, fields, and methods, but each of the fields now pairs a symbol with the type instead of just being a symbol for the name of the field. That is, fields have types now. And methods, meanwhile, we have the name of the method and a method T instead of just a method. In the method T, we have the body expression as before, but now we also have the argument type and the result type for that method. Note that the body expression can be just an xi. We don't need an xt because we don't use types inside any of our expressions in a class T. So we can reuse just xby for the method bodies. We do need a new data type for types. So a type is either an integer type or an object type. If it's an object type, then it instantiates a particular class. So we have a class name inside of an obj. Right? So only two kinds of types, integers and objects. The type check function overall for a typed Mo with classes program, we need the main expression for that program and also the list of all class declarations. So just like interp took those two things, interp_I took those two things, typecheck takes those two things. Again, main expression is still an xby because we don't need to write any types inside of that expression, other than using class names when we write new, but that's not a use of the class name as a type. That's a use to instantiate the class. And then we have the classes. Each class is, as before, the class declaration paired with the name of the class as a tuple. So we have a list of those. Overall, type checking the program means making sure that the classes are okay and then making sure that the main expression is okay. So we will map a typecheck class function over the whole list of classes. We pass in the name of the class that we are type checking, the class T declaration for that class, and then because a class's fields and methods can refer to other classes, we also pass in the whole list of all class declarations. We don't care what this map returns. We don't actually use the list. We were just using map to map over all the individual classes. As long as it doesn't raise an error, that means that those classes are okay, and so we can type check the main expression. As we do that, we may need to refer to classes. So we pass in the list of class declarations, but also we need the this type and the argument type. So remember that our interpreter for classes with inheritance starts off with a dummy object, which is an instance of the class object, and it starts out with a dummy arg, which is 0, just for this main expression. So that's why we pass an obj object and int t for those two things. Right? Type checker expressions here doesn't need an environment, but it does need types for this and arg. Looking then at the type check class part, where we've got the class name, the class declaration, and all the other classes. Inside of a class we have a supername, a list of fields, and a list of methods. And fields don't have any expressions in them for us to type, but methods have expressions inside, so we need to type check those. And we'll do that with a type check method form. Meanwhile, check override needs the method name that we are checking. It needs the method declaration, so it can look at the argument and result types of that method. It needs to know what class we're inside of, because that determines where this method comes from, and we can look to find the superclass, and then we take the list of classes so that we can look up that superclass. So that leaves us with typecheck method and check override to look at. Typecheck method takes that method declaration that we need to check, and mostly it's a matter of type checking the body expression. As we do that, typecheck expr again needs that expression. It needs the list of all classes so it can look at them, and it needs a type for this and a type for arg within the body. Now the type for this is determined by the class that this method exists in, so that was passed in, while the type for arg is declared with the method. So the method declaration has an arg type, and so we pass that in as the type for arg. As long as typecheck expr succeeds, that means the body has some type, but we want to make sure that that type is consistent with the declared result type. So we compare these two, but we don't compare them with equal. Instead, we have an is subtype function that we check, because this, the body type doesn't have to be exactly the same as the declared type. It just has to be a subtype of that declared type. Meanwhile, is subtype needs the list of all class declarations so that it can know about superclasses and superclasses and so on. If the body is a subtype of the declared type, then that's all good, and we return nothing in particular. We just return void. We just don't raise an error to say it's okay. But if it's not okay, then we do raise an error using type error. That leaves us with check override. We've got the name of the method that we're checking, the actual declaration of that method, the name or the declaration of this class where this method resides, and the list of all class declarations. We start by taking this class and find out what its superclass's name is. And then we want the superclass's method, which might be immediately in the superclass, or it might be in a superclass, or so on. So we have, in general, this find method in tree function that takes a method name and the class that we start in and looks in all the class declarations as it needs to. It may turn out that we're not overriding this method named by method name, so super method may fail. If it does, then we'll just use the method that we're checking. And it's kind of a shortcut way of handling non-overriding. We'll treat it as overriding itself, and it'll definitely be consistent. Anyway, we have method and super method, possibly as different methods, and we make sure they have the same argument types and the same result types. If so, then we succeed with void. If not, then we need to raise an error. Using type error is inconvenient, it turns out, so we just use error and report which method was overridden incorrectly.